While you're all standing and getting refreshments and so on, I'm going to take the opportunity to introduce our next speaker, who is here to speak on the sustainable building segment of the program. Erica Cochran is from Carnegie Mellon University. She's an assistant professor there in the School of Architecture. She's an instructor for graduate and undergraduate courses. That she has developed a new course recently focusing on energy efficiency and healthy retrofits. She's also a coordinator of CMU's U-Dream program, which gives recent graduates a deeper understanding of urban design, UD, urban design. Her architectural experience includes over 50 educational, residential, community, and transportation facilities. She has been honored for having the best proposal in a Department of Energy competition presented at the White House. So with that, please welcome Erica Hameen.
There's been a lot of talk about different things related to the building, and so I'm going to talk about sustainable building construction. And is Josh here? Josh, great to meet you. So Josh and I had a couple of conversations about what was I going to talk about. And I was thinking, oh my goodness, there's so many things to talk about with regards to sustainability and buildings and energy efficiency and all of those things. So where do you start? And one of the things I thought I'd talk about is just in the beginning. And also fitting because I'm from Carnegie Mellon, and one thing we're good at is numbers and data and computers. And so I figured I'd talk about some of the things that we're doing at CMU to help with the city of Pittsburgh and a few other cities around the country towards the goal of energy efficiency by talking about a couple of projects. So first I'm going to talk about big data, because that's a thing. My students, they're always like, big data, big data, big data. And then challenges to get the data. Once you have the data, what do you do? And then some strategies of solutions that we've done. So let's start with what is big data. But first, wear your imagination caps, right? So imagine if when you walked around the city, you walked around downtown, all the buildings had a sign on it. The sign told you how energy efficient the building was, how the air quality around that building was. It told you whether or not it had clean water and all the things about the building. There was a big sign on it, so you knew whether you wanted to rent or purchase from that. Wouldn't that be an interesting thing? So in Europe, interesting enough, a lot of the cities, you cannot purchase a home without them telling you what your potential energy bill will be. So the same way some cities have a grade on it to tell you how clean that restaurant is, and you can say, oh, this is a good one or not. They actually have to let you know whether this building is like an A, B, C, D, E, or F. And they use that information to even, I've talked to students in France at one of the universities, and they said they use this information to negotiate their rent. And they say, hey, this is rated a D, which means my bill's gonna be high, so I need you to cut back on my rent. So it is something that's possible. And so, I start with just data and benchmarking. But first, even before that, why is this important? We hear a lot about energy and where does it come from? Well, buildings are sucking up 40% of your energy. And then with regard to all the electricity that's used in the US, 70% of that electricity is used by buildings. So as we talk about wanting to, as a country, reduce energy efficiency, remember that 70% is coming from your buildings, 55% from natural gas, and your carbon emissions, more than half are coming from buildings. This is even higher in large cities. So in New York City, for example, that number is about 70 to 80% of all carbon emissions in New York City are coming from buildings. It's not coming from your cars. But when you think about it, does everyone here get their car inspected to make sure you pass that emissions test? Do we do that for our buildings? No. But the buildings are using more than the cars. So, as we talk about efficiency, the bar in the far left is our US average. So one of the things I hear some people say is, well, I still want to be comfortable, right? I'd like an efficient building, but I'm not willing to give up comfort. And when we talk about efficiency, we don't want to give up comfort. We just want to save money and not donate it to the utility company. That's the way I say it. So the bars as we go to the right are other places. California as a state, for example, uses less than the US average for electricity. Germany as a country uses less. And so for all of those who've been over in Europe or been to Germany, it's not like they're living in squalor. It's still they have nice looking offices, nice looking homes, and they're using less electricity. And as was mentioned earlier, they use solar panels, and they have more cloudy days than we do. And then if we start to go even further to the right, some of the buildings that are off to the right are kind of your CMU fancy designs with tons and tons of equipment and all sorts of things. So it sounds nice. Okay, let's just put a sign on the building and say, how much energy are we using? But there's challenges to getting this data. It's not so easy. So our end goal is we'd love for buildings to be efficient. But before that can happen, we need to audit the building and check it out and see what's going on. Well, before that can happen, we need the owners to be involved. But before that, there's this big hurdle that we're faced across the country, which is actually getting the data. So we worked on this for 3 years, which is does it really take 3 years to get data? And so here's why. So so imagine that Nicholas, hi, since you just asked the question, Nicholas, you are a billionaire, okay? You own about 100 buildings in New York and Chicago, all over the place. And I've come and I said, hey, I can help you save energy, and you want to figure out how much energy your buildings are using. But everyone on this side of the room, they're all your tenants. Are you going to go to each person and say, can I get a copy of your utility bill? How much time would that take? Yeah, exactly. And you guys, how much time would it take you if you had to go through your records and find 12 months of all your old utility bills? I know if you asked me for 12 months of my gas bill from Duquesne, I'd be like, oh, let me find it, let me look online. I mean, it's too much work. You're not going to do it. Why should you? So that's one of the challenges. How do we do that? So here's another challenge that we faced. The address that the utility company has on file is sometimes not the address of the building. And it's really popular. Here's another challenge. Sometimes you have places like Carnegie Mellon, for example. We have a huge campus. We get one bill. How do I know which building that is doing what? So, you have all of these really practical challenges. And another big one is that some buildings have old meters, and they just simply weren't up to date enough to be able to get the information using the computer and the internet to send it forward. And then one last challenge was, data privacy. So maybe half of you are going to take the time to tell Nicholas about your energy. The other half of you are like, it's none of his business. Because you just want your privacy, and you have the right to have your privacy. And so how do we overcome these challenges? So what we did is we formed a group called the Energy Data Accelerator to accelerate getting energy. And what we did with that is that we set a small goal. We said, look, we are only trying to help 20% of commercial buildings. We're not trying to help the entire city, just 20%. These are all the cities that joined the team. We had 22 city utility pairs, and that means that the mayor's office, as well as the local utility, agree that they will work together to solve this problem. Some cities like New York and DC had already solved the problem, so they were our leaders, helping to tell us, well, what can happen. Philadelphia is on there, Austin, Kansas City, Minneapolis. What was great about this map, if you notice, we had people from all different climate zones. We had people who vote differently, so it wasn't about, blue states or red states. We were like, look, let's all work together on a common problem, and it doesn't matter what your political sides are. We just want to figure out how we're going to save energy collectively, and all of our mayor's offices and utility companies would work together and share the information. So we did that for 3 years and shared best practices. So this way, no one had to create the wheel on their own. So smaller cities could learn from the larger cities without having to spend the money creating new technology. We just shared the code and shared the information. So one of the things we did, so Nicholas, we had a solution for you. What was discovered is that as long as there are 5 people or more in the building, if the utility company just aggregates all that data together, they can give you the total information, and then you wouldn't have to ask each person, and they still get their privacy. And you would, yeah, because you just need the total. You don't want to know how each tenant is doing. So that was one solution. Another thing is some computer code was written by a number of people at National Labs and CMU and a few other schools to basically be able to automate that data so that when it comes from the utility company and it gets into your computer, you can like just upload it right to a benchmarking tool by pressing a button and just goes upload. It was great. I mean, wonder. And then some friends of mine at CMU, they had their students actually write a code so that any Excel users, get this, if you had your bills in Excel, you wouldn't be able to upload it because the code didn't work. So that was fixed about 2 years ago. So literally, if you had it in Excel, you could say, here's Excel file, attach, upload. Then you get it all. Simple solutions, but they helped with the data access. And so in the end, it was really great, and we hit a lot of our milestones. So excluding California cities because they had some other issues going on in California that I'm not going to get into. But we were able to achieve a lot of success, and part of our success was that 2.6 million commercial customers across the United States were able to participate in uploading and streamlining their data access so that building owners could have it and everything would be automated. So I'd say, over 2.5 million customers. And when I say customer, remember, Nicholas is one customer, even though he owns a lot of buildings. So 2.5 million customers in 3 years, not bad. All right, so then the next thing that happens, one of my grad students found this, because this is how my students feel when they come to me and they're like, all right, I have all this information you told me to get, what am I supposed to do now? Right, so okay, Nicholas, you've got all this data. What are you supposed to do with it? Exactly. So that's how people feel. There's a number of things you can do. You can, use it to bring in really expensive equipment and thermographic cameras and do energy audits and a lot of other things, but this is really expensive. And so what I want to talk to you about are some free things that you can do. Yay. All right, so tools, free things. So the first thing is Portfolio Manager. This is a federal tool. You can log on. If you just Google Energy Star Portfolio Manager, you can get an account for free. It's run by the federal government. And what happens is that we're using it in Pittsburgh now. Building owners can just go in, use that Excel function I talked about, and upload information to Portfolio Manager. It will give you a score of 1 to 100 and then tell you how your building is doing. So if you get a 3, then your building's not doing so well. It means your building is only better than 3% of buildings like yours. If you get a 90, you're doing great. So now you know your buildings are doing better than 90%. So Nicholas, I know I keep picking on you, but what you can do is you can upload all this to Portfolio Manager, and we've done this for a couple of clients. I have my students doing the uploading for the client, and they can see, you know what, all the buildings that are below 50, maybe that's where you start. Because you want to keep your billions. You worked hard, right? Yeah, it's not trying to give it away. So you want to figure out who are the buildings I want to start with first. And this is one way to strategize if you own a lot of buildings or if you're a government trying to figure that out. Energy audits, there are different preliminary ones you can do. And as you go from 1, 2, or 3, it starts to get more expensive. So your level 3 is like where you have to hire an engineer to come in and they're doing a full assessment. But before you even get to that, I really want to stress using preliminary things, using Portfolio Manager, lean analysis. You may need some grad students or mathematicians to do, and then Asset Score Tool. So I'm going to end on Asset Score Tool, which is another free tool from the government. I love free. All right, so on a city scale, this is from Washington, D.C. They uploaded all of their federal buildings into Portfolio Manager, and then some students made a nice, pretty graphic interface for the government so that they could see which buildings scored high in Portfolio Manager, which ones scored low. They wanted to compare it over the course of years, but it was allowed to help the government see which buildings were the high-performance buildings and which ones were the low-performing buildings. Same thing was done at the city of Seattle. Okay, see that blue graph? What that is doing, each of those is tiny little bars. Each of those bars are just letting you know just how much energy is being used. And down at the bottom, that's telling you your building scores. So what the Seattle could do is figure out from all their public buildings, which buildings were in the red or the orange. You don't want to start working on the buildings that are doing well. You don't start on the buildings that are scoring at 80 or 90% in Portfolio Manager. You start with the buildings that are doing like 20 or 30. And so it just helps them figure out where to start. And then they use that information to strategically make building improvements to start with the buildings that need the most first so that they could get the biggest bang for their buck. All right, so that's Portfolio Manager. I'm going to really quickly talk about lean analysis, and I'm going to go through it fast because it involves a lot of regression, which my students love this, but it can be, you all just stretched, and I want to make sure you stay awake. So one of the things we did was we were trying to figure out how can we identify which buildings use the most energy if we never even had, if we never got to go inside the building. And so my grad students had this term called a drive-by, which they meant something very different, not like what you hear on the news. So they would say, Erica, we're gonna go do some drive-bys. And they meant they were gonna drive by the building. And they literally were like gonna drive by the building. And they wanted to see if they just got out and walked around the building without ever going in, and they had the bill, could they figure out things that they could do to the building to save energy? Which is an interesting idea. And they were pretty successful. So we tested it on a number of buildings in Philadelphia. All of these were buildings who said that they would give my students their energy bills to test this theory. And the students never went inside any of the buildings. They just had the energy bills and anything they could get from Google Earth and their drive-bys. So we looked at the data, and sometimes a client could give us their annual data. Some clients had their data by month, and some clients had sub-meters where they could give us their data in 15-minute intervals. So we, first step one was like, all right, let's Energy Star Portfolio Manager that I talked about. We put them in, and so we could see which buildings, who were the people that were scoring low in Portfolio Manager. Then the next step is lean analysis. So this is the regression. What we were doing is so CMU has a ton of mathematicians and computer science people, and they're doing all these wonderful things with robots. And we were like, can you use some of that code that y'all use to figure out self-driving cars and figure out robots and figure out all these things? Can we use them in architecture? And lo and behold, you could. So we grabbed the computer science people and said, please help us in architecture. We know how to draw, we're really good at it, and we're good thinkers, but you guys know how to write code. So could we work together to figure this out? And so there's this thing called lean analysis, and we basically are using math to figure out how your energy is broken down in your building, just based on your bill and some of the stuff we know about it. Interesting enough, one of the things we found out is that people are also running their heating and their cooling at the same time. And yeah, exactly. So we did this study for a bank that I will not say, but they're very big in Pennsylvania. And we showed them how certain of their banks were doing this. And the head of their sustainability guy was like, really? Thank you for telling us. So sometimes, it's really, we talk about all these great technologies, and y'all probably thought I was going to come here and tell you about some new technology that we invented at Carnegie Mellon. But some of the most basic things you can do is just operate what you have better and figure out how much energy you're using. So the red bar is heat, the green is cooling, and the yellow is all of your plug loads and your lighting loads and all those base things like our cell phones, our computers, our refrigerators, stuff like that. So you can see the building on the top, they heat and then they cool. But notice that second building at the bottom, see that part in the middle? Those are the days where they actually have the heat and the cooling on at the same time. Yeah. And I tell you, it sounds crazy, but there's a lot of buildings, commercial buildings that are doing this. And remember, some of these commercial buildings are government property buildings. So this is your tax dollars paying for this. All right. So this is, what the students could figure out from the drive-bys. They'd go to Google Earth, they would do their drive-bys, and they'd figure out whether or not they had shades on the building or what type of windows they had, all sorts of fun things. I would imagine what these buildings were thinking when they saw my 2 grad students like walking around peering through the windows. It's hilarious. And the students, so I actually had them, I gave my students, I was like, please keep my cell number in speed dial, because if you get arrested, I just tell the police, like show them my business card, tell them you're on official CMU business. And then they would do drive-bys at night. This is the funny part. They would do it during the day, and then they'd say, oh, Erica, we want to go by at night so we can see who left their lights on. And I'm like, okay, but please go together. Don't be by yourself. But they did it, and nothing happened. They're very safe. Because these were students who, I had them doing this in Philly, and none of them were from Philly. They were from like the suburbs out, and it was just like, oh my gosh, their parents are going to call me. But they did great. Their names are Tim and Zoe, and they both have amazing jobs right now. So this is just one of the things that they were able to figure out, and they found a number, like a long list of recommendations for all of the buildings that they did the drive-bys for. But one basic one was, and this is like so simple, was just the thermostat setback. So they were able to show how, all the buildings that had a thermostat setback pretty much saved a lot more energy. And so they did this for buildings with their lights on. They did it for buildings that had shading versus not shading. And so they used the information to show all of the clients, and we were working with BOMA, which is an organization of a lot of facility and building owners and managers, how simple things like shading devices and thermostat setbacks and all these things could save them money. And then they did return on investments for the clients to show them how fast they would make their money back. All right, another free tool, the Asset Score tool. If you Google Asset Score tool, it pops up. And this is another free one. And the purpose of this is that if you don't have your bill, right? So Vera, you came into a lot of money, and you also own a lot of buildings. Maybe not as much as Nicholas, because Nicholas has old money. You've got new money, but you're having a lot of fun. And you're like, you know what? I just don't want to bother everyone with how much energy. I don't want to ask them for their bills. That's too much work. I know you have this streamlined way, but But, oh my gosh. You've got some amazing people, and all your facility managers for your buildings said, we've got the floor plans for our buildings, and we can tell you all about what's happening inside the building. So you're like, cool, okay, but now what do you do? So there's this tool, and what's nice about it is you do not need a degree from CMU. You do not need a degree at all. All you need to do is know how to read and click your mouse and have internet to use this tool. So what happens is we use a lot of simulation software to predict energy. So this tool says, well, I'm going to do that prediction for you in a simplified way. It won't be as accurate, but it's going to be close enough. So what happens is, this is how the tool looks. You go into the web, and they give you these generic shapes like a square, a rectangle, and an oval, and like just different shapes. And you click which shape looks like your building. And maybe your building is kind of 2 shapes. So you'll click 2 shapes and then just like pull them together. So it kind of is like a little kiddie game, like click, 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 click. And then it'll say, what type of heat do you use for your building? And you go, oh, it's gas. So and it's a drop-down menu. You just follow the instructions and click. And if you get to something you don't know, you just say, I don't know. And then you just click like the common thing from my zip code. So it's really helpful. So once you put all of this information in, and it runs on the internet, so it's not something you have to download. So don't worry about like, oh, my computer's old. If you have a good internet speed, you're fine. Oh, 3 minutes. Okay, so it works on all types of buildings. Here's what I like about it. It gives you a report. The report, will score everything on a scale of 1 to 10. It will tell you what score your building is and what score, if you make these upgrades, your building could be. This is some score distribution that we've done for a number of buildings, showing like the blue is their current score and the little triangle dots are like where their score could be if they made these changes. And it gives you a nice report. What's nice about the report is it gives you recommendations and then tells you like fair, good, or high in terms of ranking. Like, is this something you really need to do because it's not in good condition, or you can like wait on it. And it also gives you costs like dollar signs. So I think of it like Yelp. When I go to a restaurant, my husband and I'm like, is this a $1 sign restaurant or a $3 sign restaurant? Because if it's a $3 sign restaurant, we gotta wait till our anniversary. But if it's $1 or $2 sign, we can go. So it does that for buildings. Is this a $1 sign retrofit or a $3 sign retrofit? So got a lot of value. Just an example of what we did. We did this for the city of Pittsburgh. City of Pittsburgh has something called Metro 21. It's a big kind of resource organization group where we're trying to figure out how to save energy. And we did it for a few of their city buildings, where we went in and we showed them, like, here's one of the rec centers, said it's at a 6.5, but it could be at a 9, and told them these are the things you should do. Mostly they needed to do the lighting, because see, it's like a $1 sign, and that helps. So we did this for a number of buildings, and then gave them a nice chart to say, these are the scores. Green is your current score, blue is where it could be, and then basically how much your savings could be across your buildings. So 2 free tools, Energy, Star Portfolio Manager. If you have your bills, and if you don't have any bills, but you know what your building looks like, use the Asset Score tool. Thank you.
Thanks very much. We could take one quick question. Yeah.
Tell them that the wrap up at the end, they'll have an opportunity to ask questions too.
Right, yes. So in our final session, you'll have a chance to ask questions. You'll be around, yeah. Right? So you can ask a question of Erica then.
So we can do one now?
Is there one? No quick question? Okay, so we're going to move on. Okay.
Hi there. I was wondering if this is available for residential areas as well, because we know in Pittsburgh there's a huge energy burden. So a lot of the folks there, like a quarter of the people there, 16% of their income is spent on utilities. So really trying to target, I don't know if there's data available or tools for that.
These were mostly done for the commercial buildings. We have had students use them for residential, but they don't work as well. But if the building's big enough, it is a good starting point, especially the Asset Score tool, because it, like lighting, whether it's an office or a house, if your lighting's old, the lighting's old. So it can be used, it's just not as good, but it's a good start. Thank you.